day today. If you had a great day today, let me see your expression. It means nobody had a good day. Oh yeah, explain what made your your day bad. Let me hear you. Let me see if I can sympathize with you. Okay, good. Oh yeah, welcome to today's lightning session. Um, Today our speaker is a senior engineer. I know because I have track record to prove that we have a senior engineer in the building by name Mr. Ebube Ugwu. So we'll be taking us on a very controversial topic. Very controversial. Because when I saw the topic I was first, I was like, we'll go fight. Like we'll go definitely fight. And I've prepared all the questions I have in this world. So, yeah, so I hope we all do. Because once you see the topic, you'll be shocked. You have seen the topic. Gradle overview. How many of us has used Gradle here? Confess. Or forever remain silent. You see, nobody has used Gradle here. So we will be looking at Gradle overview. And you see the reason why you should not use Gradle. Okay, you have the
Okay. Well, good evening, everyone. Thank you, Mr. Samuel Venga. Again, don't mind someone, it's just like me. Okay, so we're going to be looking at Gradle. I'm sure most of you are familiar with it or have probably heard about it if you're in the Java space. So obviously, there's only so much you can cover in an hour. So the hope of this is to give you an overview of Gradle, how it works, and reasons why you should consider using it. Now, a quick note, I'm using Linux, so we don't get support for mini software, so it tends to be buggy at times. So if at any point you can't see my screen anymore, please just notify me. Though I should be able to tell, but just in case. Okay, so we're going to look at an introduction. Um, why grid automation matters, like why do we even need grid tools? Then why grid was created, since we already have like ARMS and Maven. Then we're going to cover core concepts like dependency management and all that. And then I'll be showing you basically video with action. So everything will not just be theory. And that'll be all. So it's going to be very short and hopefully very fun. Okay, so what is Gradle? It's an open source build automation tool. Supports most JVM languages and also C++. Though you don't tend to see it used for C++, especially it's only in niche areas that you see it happen, like in game development. C++ mostly uses CMake, but for all other JVM languages, you can use Gradle for it. So it's very, very flexible and very, very readable. So that's the core benefits you'll be getting when you're using Gradle. It was created by a developer called Hans Doctor 4 years after Maven was created, because Hans was not satisfied with the issues that were happening in Maven. And what tends to happen in this software world is that whenever you create a tool and it gets traction and becomes popular, and that tool doesn't have any competition, when users are requesting how far we don't like this particular thing or there's this issue, the makers of those tools, they just relax. They don't really want to add any new feature because there's no competition, so there's no pressure. But when they now start saying competition, now it's now ginger them to start adding features and fixing bugs and listening to the developers that are using their products. So at the time, Maven was very, very popular and it had issues that most developers were just managing back then. Also, Hans decided to create his own automation tool, and then many people liked it. It became the official YouTube for Android in 2015, if I remember correctly. And then it just kept on gaining traction, especially in open source projects where people have the freedom to choose their own tools. Okay, so why do we need build automation? So if you have been using an IDE to run Java code all your life, you might have never like had to do things manually. But I guess uh, I go is that. Okay, so if you have like the Java script now, and just do something like this now. Yeah. So if you were to compile this now, you have that my this doesn't want to start. That's not do it manually. So hold on, let the yes. What is wrong with my LSP? So that's why this same manually myself. What will be okay? No, minus the deciding to advance like this. Let's start with okay, so oh, this is still not working. Okay, so I just tried to write hello world. Look how the rules of language is. Okay, so yeah. So if you have to compile this cluster now, you have to do it manually. You call the Java compiler, pass in the class, and let's say you had other source files like uh, let's say for a calendar you need like a button and input class. So you pass in all the source files manually. And that's how they're doing it before. Usually they would have a bash script to automate everything. So you don't have to like keep on typing it. But the problem with like using something like bash or any other scripting language is that it's always going to be different. Let's say the way I go to my own scripting language, the way with my own script will be different from how someone else did it. So it was not ideal for collaboration. And what if that person doesn't have bash? What if the person doesn't is using Windows? So like they needed like a sort of something that was central. Yeah. So then apart from completion now, you still have the issue of testing. If I were to write tests for this thing now, I'll have to manually run it again, compile it, because tests are basically Java else. I will have to compile it manually with Java C, then just run it again with the Java command. Then if I want to list dependencies, I would have to specify every single thing in the class path. The class path is just basically all the places that Java has to look for class files. So without that, your this thing is not going to compile manually. If you're around on manual compilation, you know how stressful and error prone it is. So that's the point of Qtools now. As the project gets bigger and complex, it becomes very, very essential to have something to manage both dependencies and completion and test cycles. So that's where build automation comes in. The first one that was out was Ants, a build tool called Ants. It's very, very old. It was by Apache. And the problem with Ants was that you'd have to tell it every single thing. Like it didn't have any default configuration. You have to tell every single thing, your project name, where you want it to look for your files, where you want it to look for test files, how do you want it to run it. So every single thing was very, very manual. So then how someone wrote his own Ants XML will be different from how another person wrote it again. So you have that same issue of portability. It's why when you're collaborating with others. So their Maven was created in 2004 with the idea of bringing convention over configuration, the problem that Ants had. So yeah, but Maven still used XML file, and the majority it was using XML was because of ants use XML, so they didn't want the context switching for developers to be too much. So once they start that familiar XML, and it will feel more familiar to the developers that already use with ants. And from 2004 to 3 years later, it's gained traction, and most new projects were using Maven. But it maybe still had limitations. The major one being the verbosity. I don't know about you, but XML is very, very hard to read. Like it's very, very cumbersome. Like any projects you have, you're seeing XML files. Anyway, it's very, very hard to read too, especially when you have bytes in it. And then the second issue is that at the time, maybe did not have incremental builds. If you have used something like if you have produced the familiar with Node.js, so um, JavaScript, anytime you are running a server now, if you just make a change to a file, it's only like adds that file. For TypeScript, yeah, it only compiles that file only. So that's incremental builds, only build the files that change. So if you make an edit in one file, you shouldn't have to compile every single thing again. You are only meant to compile that particular file. So that's maybe they had that at the time. So build times were very, very slow. And even when developers were testing it, because they didn't have any competition, they were very, very slow in adding that. So that was another issue that Gradle faced when it first came out. But now maybe it has incremental builds. Then the third reason was that apart from you can't maybe it's very, very hard to configure for complex projects. Let's say you want to uh, depending on some specific variables, you can't easily do that with Maven. You can't easily do that with Maven because it's XML. So, but with Gradle now you can because Gradle is basically code. So it's not using XML, it's using code to configure it. So you have the Gradle itself is the Java file. Then you write a script which is either Groovy, a JVM language, or Kotlin. So because it's code now, it's very, very easy to write custom logic. You can build your projects depending on any parameter you want. So you can even add environment variables to each manually without needing an extra dependency. So and then, um, this table basically summarizes the differences between the two. I think the only disadvantage really has is that it's more there's more to learn. It's like there's more to learn. Like initially when you see Gradle file, it looks very pleasant, but it was still very, very scary because you'll be wondering what's this one, what's that one. So to show you. Okay, so let's see. Okay, so we'll cover core concepts. Oh, if you are familiar with maybe Gradle also has the idea of plugins and tasks. If you are familiar with maybe just think of tasks as goals. So they're just like actions, build actions like you want to happen. Then plugins are like a collection of tasks, similar to how plugins are a collection of goals in Maven. They have dependencies, repositories where it's going to look for dependencies and build scripts. So that's the major system. Then projects. So the project is just basically, obviously, the project you're trying to build. So your current working directory, the main roots of your project, and it's actually an object in Gradle, like it's treated as an object, and the build script just runs methods on that object. So, so okay, I'm ready to create a project, but we'll do it from scratch once I start. Well, let me just show you what the so yeah. So every single thing you're seeing here is code. And because like it's using code, it's way easier to read than if this was the pom.xml file. Look how clean and easy to read this thing is. Now, all these things might not be looking familiar, but as we go on, you like realize what each of these things are and what they are doing. So every single thing is actually a method. Like this plugin is actually a function taking a closure that is basically a section of code. Even this ID is also a method taking a section of code too. So I digress. Okay, so again, tasks are just build actions. As we see, plugins are a collection of tasks that you want to run to achieve a particular goal. You have the Gradle wrapper, like Maven. You have a wrapper that you commit to your version control. So each member of your team is using the same version. So you don't have to manually install everything, making it very, very portable. Then, okay, initially when Gradle started, in Maven, you could only connect to the Maven Central repository and the private ones. And it was a pain to configure it manually. It was only when Gradle came and gave the options of connecting to as many repositories as possible that maybe now later added it because there was not that confusion. So as Gradle was releasing new features, maybe will not try to catch up. So again, Gradle also follows the convention of our configuration approach. So you write less code in your build scripts because it's really expecting things to be in a particular way, which most of us are already familiar with. So again, the Gradle also has a life cycle, but it's somehow easier to wrap your head around this compared to Maven, at least initially for simpler projects. So basically, you initialize Gradle. We see it once we start in our projects. We initialize Gradle, we configure it, we execute it. It's simpler. Like you don't have like a default lifecycle where you have to remember, okay, compile comes before test, or there's a default lifecycle like you have in Maven. So it's easier like to wrap your head around this initially. Okay, so let's that's enough talk. So let's do a Gradle file from scratch and just I'm not even this. So first of all, to install Gradle, you go to this website, gradle.org/install. Then if you are using Windows, you have to manually download it and add it to your paths, your environment variables. But if you're using Mac or Linux like us, you can either use Brew, that's Homebrew to install it, or the best way to install any JVM thing, use SDK man. I know you are familiar with SDK man, so you use SDK install Gradle, and it should automatically install it and add it to your parts. And the beauty with SDK man, you can easily manage different versions and switch between it very, very easily. It's like Node version manager, but for Java. Okay, so once you install it, you create you go to your project, the root of the project directory, and you run Gradle, and it's yes. And it's going to ask you what type, whether it's a plugin, a library, or we just go basic. For now, project name default is fine. Okay, now it's asking me to which domain specific language I want to use. Remember, I said your build script is actually just code. Initially, Groovy used to be the most popular option, but when Kotlin became the official language for Android, there were now more Kotlin developers, so there was no need to be using a different language for developing and a different language for abuse. So Kotlin now became like the default choice. Even in Spring Boot now, if you choose your B2 as Gradle, it will actually like make it. So that I choose like Kotlin as the default without even knowing. So but we're going to go with Groovy because it's still more popular because of existing projects that already use it. And I think it's easier to understand than Kotlin since it's more dynamic. No, we don't. Okay, so I think I would have opened this with IntelliJ, but think everything is faster. Okay, so let's see the files that I created. The most important ones are settings location. This one just defines high-level configurations for your projects, like the name of your projects. In simple applications, there's really not much you have to do for this file for simple applications. So then the Gradle view and the Gradle paths are the Gradle wrappers. So from henceforth, we'll be running this one instead of the one I have installed. So it's always recommended to use the wrapper over like your locally installed version of Gradle. Then you have some properties. This one is just to configure Gradle itself, not for your, it's not for your projects. If you're doing something like Android developments, like that's when you have to touch this file a lot. Then the main grid file. So there's the main thing. This is your main grid file, the grid of Gradle. Then you also have like hidden doors. So you have those Gradle, that's a hidden directory. So that it just serves as a cache. So that's what Gradle uses to do incremental builds. But it has, if it has compiled something and it did not change, it just use it rather than do it again. If it has any dependency that downloaded before, store it in the cache here. And the build directory, obviously, you don't want it to be committed to, Git. It's just a waste of space since you are building it this time. Okay, so that's okay. I think there's one I didn't cover. This video just has like everything. As we start building our projects, you'll see more files appear in this Gradle directory, the one that's visible. Okay, so after running Gradle init, we're now going to use our wrapper instead and run tasks. Okay, so this just shows us all the available tasks. I'm using some example. So this just shows us all the available tasks that we can run. Again, tasks are just like actions. So I see a specific goal, build actions. So you see we have the init one that we just ran to initialize the new Gradle build. If we didn't have the wrapper files, we run wrapper to generate it for you automatically. Then you have other ones, dependencies. This is like one of my favorite ones. It's a list all like it's show like a graph version of all the dependencies you have and the scope of each dependency. Okay, so it's also important to know that task is also a task itself, as you can see. Okay, so now I think let's add some code to this. I think I had one. Okay. Okay, first we need to create the source directory. Gradle, like maybe it expects your Java source files to be in that same convention of source, main, Java. So the same way maybe automatically expects your source files to be here. That's the same way, Gradle expects them to be here. So then you add your main. Let's add that script. Then we'll move our current as well projects main. Yes. Okay, now so we now have a default file. So this is just basically like it just prints a calendar that shows like an ASCII calendar that shows like the current dates. So rather than run this manual, I'm going to build it with Gradle. Rather than having to create this thing. Yes. Okay. So run. Okay. Yes. I've used the wrapper. So I'm going to run the build task, which if you read it, okay. Okay. I'm going to run the build task. Yeah, and it did not work mainly because primarily I have not defined uh, the Java plugin. So to define the Java plugin, you first have to configure it in the build script, and so you run the plugin method by directly using the file of the license, then the ID method and Java. Okay, so before I go on, let me just explain some Groovy basics. So again, Groovy is a dynamic language. So the most important thing to know is that you don't have to specify types. You don't have to define a variable. You do def my variable go to Ebube. And it doesn't need semicolons. So you don't have to specify semicolon. And for methods, um, as long as you have a parameter or arguments, you don't need to add the brackets. So print line will just be print line my var. But if you have something now that had the arguments, then you have to specify the brackets. So then you have the idea of closures. So the idea of a closure is just basically a block of code that you can pass around. What's it called? I can't remember the term for this, but you can pass around and then run it later. So it's like a functional programming principle or functional programming feature. Sorry. So then if you want to call this, you call my closure since you have no arguments, or you can pass it to another method. So the idea of closures and methods, that's basically like what you use most of the time. So plugins is actually a method. It takes a closure, and inside the closure you have ID method that takes this. That's all. That's all. You know, and now it works. And if you go back to okay, so now if you're going to the Gradle folder, so the Gradle folder, sorry, the build folder. I see now there's not a new build directory, and then we have classes. Inside the classes directory, it now follows that same structure that we had Java main def Ebube, and you get the class file. And apart from classes, we have something called bits, which basically contains, I don't know if you can see it, but wait, let me put this. This is a Java file, like your whole project compiled into a Java file. So if we try to run that, is then build bits. Okay, we get an error saying no main manifest attributes. Okay, this is basically saying that Java doesn't know which class to run. Like it doesn't know what's the entry points in the application. Now, even though there's one, like only one system, you still have to specify it. And to do that, you just pass it as an argument. So um, come back to our build file. Then we're going to be configuring the Java plugin. I don't know if you saw it, but it's there's the Java plugin, and that was complained. So you have to configure it. So this also in method. Then it takes an argument, which is the manifest inclusion. Then manifest now takes some attributes. Again, all these things are methods. So the manifest method is taking in inclusion as an argument. You're wondering how I need this. It's clearly defined in the documentation, but I'm being very, very careful because this is the text editor and I don't have IntelliSense. Yeah, okay. So if I were to run build again, hopefully that was enough. Yeah, so now it works because we configured it. So again, every single thing here, it's a method. It's taking inclusion as an argument. This just takes a map instead. Okay, so we've covered the basics of Groovy, covered like how to initialize the basic projects. Now we need to dependencies. Let me just use my table because I don't think we need them book. I say it's faster than manually like using the GUI to open the folder. Okay, so again, yeah, so we're going to create a test file for it. And again, Gradle also uses conventional graph configuration, so our uh, it expects our source file to be in a particular directory, which is the src main, sorry, test Java. If you don't put it here, it's not going to work and you be very, very specific. Uh, uh, okay, so again, you have this is estimate for me. Let's create the okay. My name is Go. Hopefully I am. Okay, so let's please. Yes, but yes, I don't want to manually install myself. Yeah, let's use G limit 4. I'm not very familiar with 5. Yeah, I just need to call the main method and verify that it runs. test allocation. So now again, if I try to compile this, it will fail because I have not specified where it's look for dependencies. Again, you can't find still because like we have not told you about the dependencies. So for configuring dependencies, it's quite similar. You pass the dependencies method, which takes inclusio as an argument. So again, inclusio is just a block of code. Then you define the scope. So you can see this actually a method. As I like to say, it gets is actually a method taking inclusio object. So again, this thing has arguments, so we don't have to use the brackets. Okay, so this test implementation is basically the scope of the dependency. So there are so many. There's implementation, there's compile time only, there's runtime only, there's implementation on its own, there's test compile time, there's test runtime only. So test implementation just basically means that this dependency will need to run both during compile time and during the runtime phase of testing. So when you're running your tests, it's going to compile the dependency together with it and also include its integer file that's going to run. Two group arguments, it's units. Then we have the it's also units. I can't remember the test. Let's go to maybe central repository. Yeah, so this is we have the short version and we have the long version. But we use the long version. This is an explanation video. Copy it and format everything nicely. Okay, now if you run this, it's still going to fail. And see how helpful the error messages are. Cannot resolve external dependency because no repositories are defined. It's already told you what the problem is. Like I said, like it can take any it can get dependency from any repository, whether public or private one. So you have to define it explicitly. To do that, we guess it's we pass a method. What do you think the method we call? I guess we call repositories and we call this because this takes no arguments. You have to specify the brackets. Now, good. Where am I making a mistake? Good. I did not make this in a brackets. Hold on. Yeah, sorry, I have to make this name directly. If not, it's not work. It's expecting the name to match with what I already have. This should be defined now. Let's see here. Okay, this is the second one. I guess we do this now. I think that's it didn't download this one because okay, so and this is exactly what we had in Formula One. So again, you pass in the classification method, passing a closure with the maybe central method call. And all these things are methods. Notice I'm saying methods, not functions, because they are actually operating on the projects. So it's treating your projects as an object, and in that object you now have all these methods that act on it. And calling the build to download the dependency and build the file. But it was so fast, but I only saw it. If I'm not mistaken. There is. Okay. I've never had to manually write. Okay, now so obviously following this. And it's happened so fast, so you can't see it when it's running. Just let me just use until this please. Yeah. That was making it fast. Yeah, because they already defined the dependency. So again, look how clean and neat everything beautiful is. You don't have to define so many things. It's so simple sometimes. Like if I was defining environment variables, I could use like right here inside the base script. I don't need to add any extra dots and dependency or anything. You can even customize like if you're writing like pure serverlets, you're not using Spring Boot. You can like define when you want it to run depending on whether an environment variable is set. So if you wanted to run one with different profiles, like run one for development, one for production, if you define it here, because again, the script is just basically code. It define like profile call system dot sm because it's code. So like you can add logic into it. So that's what makes another thing that makes Gradle so useful because it's very, very easy to configure it. So if you have complex build systems, that's why it's very, very good for Android because like on Android, the building step is very, very complex. So it's very, very easy now to like build with logic than if you're using Maven. Maven doesn't support that. It's just XML file. Okay, and then the final thing that I love so much is the dependency resolution. Like just the investment. I choose the graph. And you can see, okay, you see during it is classified under the test and compile class path because it's used during the test and compile phase and also in the runtime phase. That's why it's appearing in both. So the test implementation is just the combination of these two. So it's way faster and way easier to resolve dependencies with Gradle if you understand it than with Maven. Okay, so we have already covered the common commands. Clean just removes like the current Java we have. So the big question is, should we now stop using Maven for Gradle? The answer is a big fast no. Now, better does not always mean better. Right? And we have the same issue with when Kotlin was created. So should you stop using Java and start using Kotlin? No, because Maven is still the most popular beauty for Java. In fact, the major thing that made Gradle gain traction was Android, which is also what made Kotlin gain traction. But just because something is faster or better doesn't mean people are going to switch. So you should only use Maven if your project requires it. Like you need logic to make the build more flexible. And like that's need like you can justify the time you spend relearning and migrating your project over to that. You need faster builds. Again, because like there are many optimizations that Gradle does to make the build time faster because if your project is very, very big, the build time for Java can become very, very slow. You have better customization, or you just want to learn something new. If you are tired of using Maven, you just want to see how great it was like. You can just learn it. So if you have, if a project ever comes up or that uses Gradle, you won't be left feeling stranded. So again, build automation saves time, remove errors. Gradle is more readable, more flexible, and way, way more powerful than Maven. And it has better dependency management than Maven and all the other features. And Gradle makes it so easy for people to migrate over. Like they try to make so many things compatible. You can even generate a form.xml file in Gradle. So they try like they consider people coming from Maven to Gradle. And also the performance is better. That's if you know what you're doing. So Gradle can also be slow if you don't like write this thing well or if you don't understand like the whole cycle of it. So again, the references, Gradle has very, very good documentation, way better than what Maven has. I know it's because of the people who made it, but I think Maven now is under Apache, right? I think it's under Apache now. Yeah, it's under Apache. Apache has, I don't say they have very good documentation, but they make the documentation for experts, like for people who don't even need documentation. So most of the time, it's very, very hard to read. But Gradle has way better documentation. Then one of the best one is this guy from Gregory. Like his YouTube channel, he has like a course on Gradle that you have to take once here, and he has like a very small free ebook, which is this a website. Like this guy just dedicated so like to Gradle and Java. So I think that'll be all. If you have any questions or comments, I'm sure I made a mistake somewhere along the line. Uh, yeah, over to you, Sam. Oh, Gloria.
Thank you very much, Ebube. Well done. Thank you for that amazing section on Gradle. But as for me, as for me and my Maven, we are stuck together. So please, if you have any questions for Ebube, just raise up your hand and or you can anyone hear me?
Yeah, I can hear you.
Okay, if you have any question or contribution or confusion, you can just raise up your hand and ask your digital hands, I mean. Okay, Ebube, thank you. It seems like you did a very good job with the explanation today and everybody understood what you said. If you are joining us for the first time, I want to welcome you specially to NaijaJUG. I'll be dropping the link to our channel so you can follow us and join the group on WhatsApp. You can just signify so I can send it to your DM. Oh, okay. Gloria will be dropping it on the channel. I think Gloria is back now. Yeah, thank you so much for joining us today. I'll be handing over to Gloria. Hi, Gloria. Welcome.
Thank you so much, Rosemary. I was having issues with my network. Ebube, I've always trusted. There's no time we will have a section and there will be a question. I've never seen or witnessed. Thank you so much for for that section. All right, so I believe everyone we have here, they're already in the group. So except for Balogu Benga. I don't know if Balogu Benga is same as Balogu Oluwatobi. So, okay. All right, thank you everyone for your time. And we'll be meeting again next week, Tuesday. Yeah, for another great section. Please do well to share our flyer for the monthly section. The registration so far is very poor, very, very poor. So do well to repost, invite your friends, share it among your communities. In fact, even your church self, share it in your church group. So we need a lot of turn up for that section. A lot, please. Thank you very much. Do have a lovely night ahead. Ebube, I'm coming to your DM. All right. Thank you, everyone. Good night. We'll draw the curtain here.
Yeah.